Welcome back. We're going to be talking about putting everything together that we've been doing for the last couple of lessons. In the first lesson, we looked at how to just find the characteristics of a rational graph from the graph, and then we looked at how to find those same characteristics if we didn't have the graph but just had the equation. Well, today we're going to find those characteristics from just the equation, and then we're going to actually start graphing. So let's go ahead and jump right in. We'll start out with the fact that we have our before factoring steps and our after factoring. So I'm going to put before factoring. The first thing we do when we are looking at our rational function is we find our y-intercept. And the y-intercept, remember, just comes from what we get when we plug 0 into our function. So if I plug 0 into this function everywhere I see x, I'll have 3 times 0 squared minus 3 over 0 squared minus 0. Now that all ends up being negative 3 over 0. We know that that's not possible. It's not a real number. So what that tells us is there is no y-intercept. All right, the second thing we do when looking at our function before we factor is we try to determine if it has a horizontal or slant asymptote. And that's all based on the exponents, the highest power in our numerator and our denominator. So because our highest powers are the same, we've talked about how we just have to use the ratio of the numbers in front of those highest powers. So that's going to be 3 and 1. So my horizontal asymptote, it is horizontal, not slant, is y equals 3. I'm going to highlight that so I don't forget where that piece of information is. Okay. Next up, we're going to factor. So our next step is to actually go through and factor the function. Now, I'm going to take that function and I look at the numerator and try to decide if there's maybe a greatest common factor in either the numerator or the denominator, and it looks like I have one in both. So in the numerator, I have a greatest common factor of 3. When I factor out that 3, I get x squared minus 1. In the denominator, I have a greatest common factor of x, and when I factor out the greatest common factor, I get x minus 1. Now, I can factor that a little bit further because the numerator is a difference of squares. So I factor it, and I get 3 times x minus 1 times x plus 1, and in the denominator, I have x times x minus 1. Okay, so the next step after we factor is to look for any holes in the function. And remember, holes come about because of giant ones. So I'm looking for any possible giant ones, and I see there's a giant one right there. What I know is from that giant one, I take the factor and I determine what would make that 0. So I'm looking for holes in the function, and I'm always trying to find the coordinates of the hole. So for the x coordinate, I figured that out by just taking the factor that I found, that's a giant 1, setting it equal to 0, and I get x equals 1. And that's the y coordinate, or sorry, the x coordinate. Now to find the y coordinate, I'm going to have to take the reduced form of the factored rational function. So I reduce it and I get 3 times x plus 1 over x. And what I'll do is I'm going to plug in whatever I just found for the x coordinate into this new expression. So I will get 3 times 1 plus 1 over 1, which is going to be 3 times 2 over 1. So that's 6. So the coordinates for the hole are 6. Now I'm going to go ahead and highlight that too so I don't forget about it. Okay, the next thing we do is we look for any vertical asymptotes. So in our function, remember, vertical asymptotes come from what makes the denominator of our newly reduced function 0. So in the denominator of my function, I just see x. So the only thing that's going to make that 0 is when x is 0. Let me label that. So that's our vertical asymptote. And then I look for my x-intercepts. So again, the x-intercepts come from what makes, let me highlight this, what makes the numerator 0. So we look at the two factors in the numerator and we think that we can't ever make just 3 be 0. There's no x value that will make 3 0. So we look at that factor, x minus or x plus 1. So this is our x-intercepts. We take the factor x plus 1 and we say what's going to make it 0, and that's just going to be when x is -1. So my x-intercept is not just -1. That's not how I write it. I write it as an ordered pair, -1, 0, because that's the coordinates for that x-intercept. Okay, I'm going to save end behavior and domain for just a second because I want to actually go through and graph this function. So I start, I would just go right on down the line, right? I'm going to think about what my y-intercept, and if I can graph that. There is no y-intercept, so I don't have to worry about that. Next thing I graph is my horizontal asymptote. Now I know a horizontal asymptote is a horizontal line. So I'm going to graph a horizontal asymptote through the y value of 3. So we have this horizontal asymptote. So I graphed that. Couldn't graph that. Next up is any holes in the function. So I see that I have a hole at the point 1, 6. So 1, 6 is right there, and I just put a hole in the graph. I have a vertical asymptote at x equals 0. Well, that means we have a vertical line through the x value 0. And then finally, I have an x-intercept at -1, 0. Now, at this point, we have to actually draw in the rest of the graph. And what gets a little confusing is thinking about, well, what does it look like? But remember, the asymptotes are what are shaping this graph. So I know that my function is going to stay very close to any asymptotes that are around it. It can't cross through a vertical asymptote, and it could possibly cross through a horizontal or slant, but we know that at the very least it's going to stay very close to it as it goes out away from 0, 0. So what helps me here is that I already have an idea of where this graph is going to be placed in on this right side of the vertical asymptote, and I can also see on the left side of the vertical asymptote about where it's going to be. At this point, we can make a really quick sketch, and this is really all we're looking for here is kind of a sketch. If you wanted some more detail, you could plug in a couple more values for x, and I would plug it into this reduced form of the function. So if I plug in, let's say, 2 into this function, I would get 3 times 3, which is 9, divided by 2. So I'd get 4.5. Right? So at 2, I'd be at the point 4.5. That gives me another idea of what the point might be. I could plug in -2, and we would get negative, well, let's see, -2, 3 times -2 plus 1, that's going to be -1, -3 over -2, it's -1.5. We're going to get something, that'd be +1.5, sorry. I'm just doing these calculations quick in my head. And here's the thing, you don't have to do this step. I'm just showing you if you wanted some more detail, you could. But what's really important here is just knowing the idea that we're going to be approaching those asymptotes. So I know that as we continue to move up, I'm going to stay really close to that vertical asymptote. And then as I move down, I'm going to start to approach that horizontal asymptote. And then I also know the same thing's going to happen here. I'll stay very close to the horizontal asymptote, and I'll approach that vertical asymptote. These are rough sketches. They don't have to be perfect, right? We're just looking at getting an idea of what the graph looks like. And what you'll start to notice is that these rational graphs, I like to say, don't make good neighbors, because you'll never see them living right next to each other in two quadrants that are adjacent. Notice how these are opposite from each other. That's pretty typical for your rational functions. They just don't make good neighbors. They like to be away from each other. Okay, let's talk about another one. So you'll notice I didn't talk about end behavior or domain. We've talked about that a few classes already, so I'm hoping that piece of this is okay. And if you do have questions on it, we can talk about it in class when we're done with the videos. All right, next up, we'll move through this one a little bit quicker. So before factoring, I look for my y-intercept. So I plug 0 in for x. That's going to give me -3 over 0 again. So we don't have any y-intercept because that's an undefined number. Next up, we think about whether there's a horizontal or slant asymptote. Again, based on our powers, our higher power this time is in the denominator. And if you remember, that means that we have a horizontal asymptote, and it's always y equals 0. Okay, next up, we factor. So factoring our function gives us x minus 3 in the numerator. Can't really do anything else with that. And then we can factor out a GCF. Now what's interesting is we get x times x plus 3. All right, so after we factor, we think about any holes in the function, and those come about from getting giant ones. Don't have any giant ones here, so there's no holes. Okay, next up, we think about any vertical asymptotes. Vertical asymptotes come from whatever make our denominator 0, and there's actually two factors this time, x and x plus 3. So if I set both of those equal to 0, I'm going to get x equals 0 and x plus 3 equals 0, which leads to just x equals negative 3. So my two vertical asymptotes, we actually have two this time, are x equals 0 and x equals negative 3. Then I think about my x-intercepts. Okay, and for my x-intercepts, I look at the numerator, and I see what makes the numerator 0. So I make x minus 3 equals 0, and that leads to x equals 3. Remember, though, we're talking about a point, so we write that as an ordered pair. So my coordinates for the x-intercept are 3, 0. And then we can start graphing. So we go right down the list, right? We think about y-intercepts, which there aren't any. We look at horizontal asymptote at y equals 0. So we draw ourselves a horizontal line through the coordinate y equals 0. There aren't any holes. We have a vertical asymptote at x equals 0. And then we have an x-intercept at 3, 0. Now, you might be wondering, hey, that's on the horizontal asymptote. It sure is. So this is actually a situation where we do sort of need some more information. So I'm going to stop and pick a couple of easy points to graph and plug them in. So I'm going to pick a couple, I'm going to find 2 more points so that I can actually start graphing this. To do that, I'm going to pick the value negative 2. So I'm just going to make myself an XY table here. So if I plug in, let's start with positive 2. Now I'm going to plug it into my factored form because it's easier to work with. So I have 2 minus 3, which is negative 1, over 2 times 2 plus 3, which is 5. So I get negative 1/10. So when I'm at 2, I see my value is negative 1/10. All right, well, that's here. It's below the horizontal asymptote. Let's just try 1 just to be safe here, okay? So I plug in 1. I get 1 minus 3 over 1 times 1 plus 3, and I get negative 2 over 4, which is negative 1/2. So I can see at this point it's starting to curve down, and that's helpful information. So we can sort of see what's happening on the right side. It does this. Now it crosses over, but it's going to stay really close to that horizontal asymptote. Now you could pick a couple points in the on the left of that vertical asymptote. So for instance, let's say I picked negative 1. All right, negative 1. I'm going to get negative 1 minus 3, which is negative 4, over negative 1 times negative 1 plus 3, which is 2. So we get negative 4 over negative 2, which is positive 2. So at negative 1, we're at the point 2. That tells me that my graph is going to be above the horizontal asymptote on the left-hand side of my graph. I don't really need any other points there. I can just do this, and that's a good enough sketch. And again, it follows that rule that they don't live next to each other. They live kind of diagonal from each other. Okay, one more. I went ahead and started this one. We've got our y-intercept. There isn't going to be one. I promise you there will sometimes be y-intercepts. Next thing we do is we think about if we're going to have a slant or a horizontal asymptote. And we look at our exponents. And the higher exponent this time is in the numerator, which means it's going to be a slant asymptote. Now, to find our slant asymptote, we have to do our division. So we set up our box, okay? Everybody sets their boxes up just a little bit differently. Sometimes you may see people write what you're dividing by over here. I tend to write it over here. So I'm going to write my 3x squared minus 9x on the left side. And then what I'm trying to make sure I get along the bottom. And I have all my powers that I need to have. They're in descending order, so I'm good. So I know I start out with x cubed. And I ask myself one of two things. What do I multiply 3x squared by to get x cubed? Or what is x cubed divided by 3x squared? So really, that x cubed is 1x cubed. So I'm saying 1 divided by 3, which is 1/3. And then x cubed divided by x squared, which is just x. So now I know that top length. I can multiply it by -9x. I get -3x squared. Now, that needs to add up. These two boxes need to add up to positive or -x squared. So that means this is going to have to be 2x squared. So then I go through that same process again, and I ask myself, what would I multiply 3x squared to get 2x squared, or work backwards? What's 2 divided by 3? And that's 2/3. And x squared divided by x squared is just 1. That's when we stop. And here's how you know when to stop. When you have what looks like the equation of a line across the top of your box. And when I look at this, I see an equation of a line. So my slant asymptote is just y equals 1/3 x plus 2/3. That's my slant asymptote. Okay, I'm going to go ahead and factor, find the vertical asymptote, and I'm just going to go ahead and factor really quickly. So you can pause the video here and factor as well. So if you factor, you get this. Now the next thing I look for are any holes in the function, right? So holes come about from giant 1s. Well, do I see a giant 1? I actually do, and this is a very common one that's missed. It's that factor of x over x. So I ask myself, what would make x be 0? And that's going to be the x coordinate of the hole, and that's just when x is 0. So 0, and that again comes from when x is 0. That's the x coordinate of the hole. Then I go ahead and I reduce that fraction. So I rewrite my factored form after it's been reduced. And I plug 0 into that. So if I plug 0 into that, I'm going to get 0 minus 2, which is -2, times 0 plus 1, over 3 times 0 minus 3. So that's going to give me -2 over -9. So the y coordinate of the hole is just 2/9. All right, I'm going to pause the video again here. I want you guys to go ahead and try and find the x-intercept and the vertical asymptote. Okay, so hopefully you found there were 2 x-intercepts and 1 vertical asymptote. Now it's time to start putting that stuff on the graph. I'll walk you through a couple of the pieces, and then I'll have you finish up on your own. So again, no y-intercept, so we don't need to worry about graphing that. But we do need to graph our slant asymptote. And this is when I want to be careful how I do this, okay? Because this is just a guide. This is not actually part of my graph. So the y-intercept of my slant asymptote is 2/3. Okay, we're looking at this equation. The y-intercept is 2/3. So I graph 2/3. Well, that's going to be maybe right about there. Okay. And then my slope is 1 over 3. So I go up 1, right 3, and I put my point there. And I'm going to do that a couple of times, just so I can get an idea of what this graph looks like. And then I just really carefully, remember this is an asymptote, so it's a dotted line. I put that into my function. Okay, I'm going to pause here. Go ahead and try and put the rest of the information on there, and then we'll finish up graphing together here once we come back. So here's what you should have. The hole in the function's a little weird because it's just below the slant asymptote, but just above 0, and there's not a lot of space there. So you just kind of put it as close to 2/9 as you can get. And then I can clearly kind of see the behavior that's happening with this graph. Let me do this with a different color, actually. It's doing this, and I don't draw through the hole, and then it starts to follow that vertical asymptote. So I have this kind of weird slant to my graph, and this is what it looks like. Now, I can plug 4 in and plug 5 in to get a couple of points on this graph, but here's the thing. Again, we don't really want you to get too wrapped up in being super precise. We want a quick and accurate sketch. So I know, because we talked about earlier, that these functions don't like to live next door to each other. Okay, so I'm not going to see anything here, and I wouldn't see anything here because then it wouldn't be a function. So the only other place where I would see my graph would be up here. So really, I can just kind of say, all right, well, it's going to look something like that. It's going to follow along the 2 asymptotes. Again, not really being too concerned with being super precise. All right, So for tonight, there are a bunch more problems on here. We're not going to have you do all of them. For tonight's homework, let's just do numbers 6, 7, and 9.